Hello! The purpose of this video is to introduce SSSOM Curator. This is a piece of software that supports the curation of semantic mappings in the SSSOM format. It also has a full workflow for predicting mappings, either using lexical matching, lexical embedding similarity, or some other kinds of custom mapping workflows. It also has a front-end web-based curation interface for quick curation of the results. It also has a lot of tools for exports, testing data integrity, summarizing the results of curation, and whatnot. We're starting here on the SSSOM Curator documentation. This is the place that anybody can go to get started. In this video, I'm going to show two different ways to interact with SSSOM Curator. The first way is going to be through a pre-existing instance of a project created with SSSOM Curator called Biomappings. This is a place where we've done biomedical ontology and semantic space mappings, for example, between the gene ontology and the medical subject headings. In the first part of this tutorial, I'm going to show how to use biomappings, which wraps SSSOM Curator to make predictions for new mappings. In this example, we're going to use the IUPAC Goldbook and the chemical methods ontology. In the second half, I'm going to show you how you can set up your own SSSOM Curator project and run it with your own custom workflows and build up your own set of SSSOM files for both predictions and curations. All right, first step is we're going to go to the Biomappings GitHub page. This is a project that uses the O3 guidelines, which means that all of the data and all of the code that runs this project is all on GitHub. So I've already got that in a tab behind here. I'm going to use a GitHub desktop to clone it, and I've already done that. So let's check to make sure that we're up to date. Good. The first step in any curation project is to make a branch. So I'm going to make a new branch to call it curate IUPAC. All right. The next step, I'm going to go to my terminal. I'm going to change into the directory where Biomappings is sitting, the source code repository. The first step I'm going to do now is, it's not the first step. I'm going to activate my virtual environment where I have Biomappings installed. So you typically need to do something like pip install -e dot or uv pip install -e dot. That installs the package in editable mode, which means that the data that's inside this package is linked into the site packages. So the SSSOM files are actually living inside the source code for the Biomappings Python package. Anyway, all that being said, you need to make sure you install it this way, and then we can use the Biomappings CLI. And actually, I've already got autocomplete, so we can say Biomappings help just to see what's available. Any SSSOM Curator repository will get a CLI that looks like this, that has several commands, a command for making predictions, a command for summarizing the contents of the project, which means like generating charts and tables, a command for testing the integrity of the SSSOM files with respect to the prefix maps and to make sure that the data is actually in the correct format. And then there's also the web command, which lets us go curate. And I can explain the other ones in a different place. Anyway, we're going to check out the predict command. Currently, there's a lexical workflow that's built in here with a couple different options. So we're going to predict lexical, and then also look at the help there. There's a couple different methods. The first and the default method is to use grounding-based lexical matching, which means that the names or the synonyms for the entities from one ontology or controlled vocabulary are compared against the names and the synonyms from another one, and the best match will be kept if there's multiple potential matches between different synonyms. That's the simplest workflow. Named entity recognition is useful. For example, I wrote a blog post about mapping chemical methods ontology to icon class, where the labels or the description strings within icon class are very long and a little bit more specific about describing what's inside paintings, and only parts of the labels or parts of the descriptions would correspond to entities in chemical methods ontology. So named entity recognition is when it's not the complete match to complete match, but a complete match to a partial match. And then the last one is embedding, which is when the name, the description, the synonyms are all put into a small language model, which vectorizes them, and then vector similarity is calculated between each term. So the vectors represent the meaning of the content, which means that small changes in punctuation will get abstracted away, and that is also useful. It's a little bit more high recall, and it also will be a little bit fuzzier. So anyway, we're going to just use the built-in grounding workflow. And this workflow also all depends on a piece of software called Pyobo, which is a wrapper around the code that's needed to download and get ontologies and also process them to extract all of these names, descriptions, synonyms, etc. This is also importantly based on the bioregistry, now called Semantic Farm, to make sure that the identifiers for all these entities are standardized. Anyway, all that being said, SSSOM Curator has a very good set of defaults built in, so we don't actually have to touch any of these settings. We can directly write biomappings, predict, lexical, and then we're going to go between Goldbook and CHMO. All right, so once we run this, we're going to start downloading the resources, parsing the resources. We may get some warnings, but this isn't super important for right now. This just shows that there are some parts of the ontology which could be updated to be a little bit more semantically correct. Anyway, that's just warnings. We can continue on. You'll note that this went relatively quickly. I do already have the chemical methods ontology downloaded and cached, which means it just had to parse the OBO file. And Goldbook actually takes quite a bit of time to download all of the JSON files from the website. So I also have that cached. This could take on the scale of an hour or 2 hours if you run it locally. But anyway, you don't have to because we've generated 507 predictions. And because we're in this editable mode, all of those predictions are now going to be propagated back into our biomappings repositories, SSSOM files. So we're going to hop back out of the terminal into the GitHub desktop interface, which is going to show those changes. Good. And we can see that the predictions file within our biomappings project has now been updated with all of the predictions. This is a good place to make a commit and just check in, say add predictions between IUPAC, Goldbook, and CHMO. Good. I haven't pushed yet. Anyway, we're going to jump back to the terminal. The next step is I can do biomappings web. This opens up a curation interface that's ready to go. Note that this curation interface has not only the mappings that we just predicted, but all of the predicted mappings that were already in the repository. Why does it do this? Well, it's useful to keep track of what has been predicted. So other people, one, don't have to do the predictions themselves, and two, just so we can keep track of them over time. So what we can do is we can search for Goldbook. We can search for any of the prefixes of the subjects or objects. We can search for names. And anyway, once we search, we'll get a subset of things and we can start curating. So yeah, this part is up to you how you want to do it. All curations are assumed to be exact matches. So you have a thumbs up button that says, yes, these are an exact match. You have a thumbs down that says these are not the same thing. If we know that one of them is broader, we can hit the broader button or the narrower button if we know that they are related. Or if we're not sure, we can click the not sure button. This is actually very useful because it shows that somebody has taken a look, but it probably needs to be looked at by an expert. This enables not just experts, but also people who are relatively well informed about how mappings work, but not super into the field to basically do a lot of work quickly. And they can just say when they're not sure rather than making bad choices. So let's see what happens. I'm going to click yes, Imperimetry in CHMO and Goldbook. These are the same things. This is pretty obvious based on the labels and just my knowledge of the domain that these are related resources. So I'm going to click the thumbs up button, and it's going to take a second the first time it runs, and it's going to update. So this isn't a very complicated web app. It actually has an internal state that's running in the background that updates every time. It doesn't have some kind of fancy model view controller. This makes it very, very easy to maintain, which is super important. But now that we've made a curation, let's take a look at our GitHub desktop, and we can see that the lines from the prediction file about that curation we just did have been deleted, and in the positives, the accepted curations, we've added a line. It also includes information about my ORCID ID and about the tool that was used to do it. Similarly, if we find some things that aren't mapped to each other, so I'm just going to, as an example, I'm going to press thumbs down on one of these. Well, maybe we can look for a good example that's not the same. Let's say well, these probably are the same thing, but I'm not aware of it. So let's say that I make a bad curation. I say, yeah, these aren't the same. So thumbs down. Now we go back to GitHub Desktop and we can see that yet another prediction has been removed and now put into the negatives file. Okay, so there's two ways we can continue from here. If you don't want to interact with GitHub Desktop very much, there is a nice little commit and push button. So this will take care of making a commit of all of the changes, and then it will push it to GitHub. We can also just do the commit ourselves. So I can say, did some curations, commit, and then push. Okay, well, that's basically all of the stuff that happens here. Once we make a push, the first time we push, we also have to create a branch. That's why it goes a little bit slower. We can create a pull request. And the nice thing is once we create a pull request, Biomappings already has a workflow for testing the data integrity. So it makes sure that all of the things that we've done are correct, make sure there's no duplicate mappings. Because we've been interacting through the web interface, it's already guaranteed that none of those things happen. But just in case other people are interacting with the SSSOM files in different ways, this keeps us sane and safe. So these run within the unit tests. Now, we could also go back into our terminal, and we can now turn off the web app. And we could also run Biomappings test. So you see, we get several tests, they run, and they're done, and we're happy. If we wanted to use this in a CI/CD framework directly, it returns the correct error codes. Okay, so all that being said, that was reusing biomappings. Now, not everybody's happy to, well, let's say at the beginning, biomappings was envisioned to be a center for community curation. Similar to bioregistry, it might need a rebranding, but yeah, well, if you want to create your own parallel repository where you do your own curation, you don't want to use biomappings, I'm going to sort of do the same workflow that we just did, but I'm going to show you how we would go about doing that ourselves. So, okay, first step is let's create a new repository. I'm going to make a private repository because I'll delete this at the end. So let's call this test curator. So I create my repository. Let's add a README in there. And then I'm going to download it with GitHub Desktop. Okay, so now back to the terminal. So we're not working on biomappings anymore. Now we're going into a fully independent curation project. So I can cd into test curator. And rather than using the biomappings command, I'm going to use the SSSOM Curator command. Now there's two things that you could do. You could already have it installed with like uv pip install -e, or no, we don't need -e here. We just do SSSOM Curator. I've already got it installed, so I'm not going to do this again. So now I can run SSSOM Curator and then some command after it. So let's look at how that looks with help. It's got all the same commands we saw before, but it also has this initialize a repository command, which we're going to rely on. So if you've already got it installed, that's one way. You can also use something like uvx SSSOM Curator. So uvx will install it and then run it all at the same time. So this is nice and managed for other, yeah, it depends if you have the code downloaded or you uv pip install it. This is maybe the easiest way, and we get the same kind of thing after it installs it. So you see it took a couple seconds to install it, but the second time we run it, it'll be instant. So what we do is now that we're inside our test curator, we're going to run SSSOM Curator init, and that says, hey, it looks at the name of the directory, and then it creates a project with that name. And then it asks this question like, is this the Perl base that you want to use? What this means is that when we export all of our files, we have multiple different SSSOM files that get combined together. They need to have a URL that's its identifier. And so it's going to be based on this one. So most of the time you can probably just accept this. If you come up with a really generic name for your project, you might want to change this. And if you have your own configuration for how you want to resolve things, you probably want to change this, but this is a good place to start. So let's just hit yes. Let's look inside the repository now and see what's been created. We've got a license file. So SSSOM Curator, everything it creates is proactively pushing you to license your curations with CC0. It has a README, which explains a lot of the things that I'm explaining right now. It also has a data repository, which has our curation files. Right now, there's nothing in any of them except for a couple tiny little examples, which are sort of trivial and not real ones. It also has the SSSOM Curator.json, which is where all of the configuration for the project goes. By default, it's configured in a way where stuff just works, but you might want to look in there and make some updates to make nicer exports later. And then there's the main.py, which basically wraps the commands that we've just been doing. So now you basically have two ways. You can use SSSOM Curator again. We can use it the same way we used Biomappings before, and it just knows, because we're inside a repository that has this configuration, it just knows what to do. So we can also do SSSOM Curator, predict, lexical, Goldbook, CHMO. Or if we don't want to use that, we can potentially change the way SSSOM Curator works inside this Python file. And then we can run it via the Python file. So we can run uv run main.py. And then if we look at the help for here, just giving it a second to install everything, it also has the same kind of commands. But this does give us some flexibility, because you might want to arbitrarily extend SSSOM Curator in certain ways. For example, if you have prediction workflows, it's got a plugin interface where you can add, let's say, graph machine learning based mappings or LLM based mappings. Okay, anyway, all that being said, let's, we have now 2 or 3 different ways to run this. Let's just use the SSSOM Curator interface this time. And I'm going to run predict, lexical, Goldbook, CHMO. While that's running in the background, why don't I hop to the GitHub desktop, which will now reflect the fact that all these files got added. So you can see here's our negative with an example, our positive file. Now, I just ran the predictions, so now we've got some predictions in here. We've got our license, we've got our main.py, which you can see is actually relatively simple. We've got our README, which contains a lot of explanation on like how this works. So this is helpful for, in case you forget how some of these commands work or you need a little bit of help. And then we've got the SSSOM Curator.json configuration. So this is a place where you can add more SSSOM compliant metadata. So the ID is one of the required fields for SSSOM mapping sets, but you probably also want to add a description, maybe a nicer title. This is the place where you can do versioning. The license is written here with the SPDX identifier. In case you want to modify and make the curation interface branded, there's also a couple options for that. If that's interesting for anybody, let me know and I can extend it as well. So back to terminal, same as before, we did our predictions and now we can go and do our web curation. Now this time, Biomappings has a couple sneaky things added inside it to make it so it recognizes when I'm the one doing curation or when other people are doing curation, and it automatically guesses their ORCID. But here it's asking me for my ORCID, so let's find my ORCID ID and copy paste that in here because it wants to keep track of who's doing the curation. So here we are, same thing before. Now we see Semantic Mapping Curator. It's a little bit different branding than the Biomappings interface, but it's like the same code running all of it. And we basically can do the same thing. We can start saying yes, limit of quantification, those are the same thing. Self-assembly, those are the same thing, blah, blah, blah. And then if we hop back into GitHub Desktop, we can see the positives mapping file is now filling up with the curations we did. Okay, so that is how to do starting a project. That is how to do making predictions. That's how to do curating predictions. The last part to this would be to run something like the export command. Now, if you're in Biomappings, the original project, it's set up with the continuous integration, continuous delivery system that when somebody makes a push to the main branch that has changes in the SSSOM files, it'll automatically run this and regenerate everything. But if we're just sitting here on our own project and we want to run it whenever we want to run it, we can just run the command export. Oh, that's not the name of the command. What's the name of the command? Summarize. Okay, and because we didn't configure it already inside our SSSOM Curator.json file, it says, hey, you need to tell me what's the output directory. That's a good point. So why don't we make a directory for output, and then we can do output directory output. All right. Good. We got an error because of the example from the first line. That's fine. But now we can see that we output some summary pictures and so on. So we can then go into our GitHub desktop. We can take a look at these. So the summary shows what are the prefixes used, what are the kinds of relations that get used. It gives some background on who are the curators. And yeah, and there's a couple other workflows that give a little bit of insight into maybe some of the problems with curation. All right, so that all being said, the next step is to make a commit to Git, and then you're getting in a pretty good place. The other command, besides summarize, which I think is worth talking about, would be the merge command. Yes. So the merge command is what takes all of the different files, because we have these 4 different files, one for prediction, one for correct curations, one for incorrect curations of incorrect mappings, and one for unsure. And when we want to merge them together into one single SSSOM file, we're going to use the merge command. Now, again, in Biomappings, this is all done for you automatically. I am thinking about how to improve the template created by SSSOM Curator in it, so this automatically gets done as well. Okay, so let's say the SSSOM directory is also something that's required, but we could configure it. Let's also put it in output. Oh no, predicate modifier is not an index. Well, no demo is perfect. Looks like I'll have to look into this one. But rather than quitting here, let's go back into Biomappings. And we can do Biomappings merge. Hopefully this one works. Okay, good. We can see that we're writing out SSSOM JSON, SSSOM OWL. This is mediated by the SSSOM Pi package, which implements a workflow for outputting JSON and OWL. And we kind of get this for free because SSSOM has been standardized using LinkML. Of course, there's several issues with LinkML that make this a little bit rigid and problematic, but for now, these are very simple kinds of exports, and they're quite useful if you want to incorporate SSSOM into an ontology. It's much nicer to curate in SSSOM files and then merge them into your ontologies later, rather than using the ontology interface like Protege for doing curation. JSON is, I think, just regularly useful if you want to consume and send JSON files to different places. In my opinion, the TSV is the best format for SSSOM. It really does capture the fact that SSSOM is supposed to be for a simple standard for semantic mappings. And yeah, so while this is going, Biomappings is quite large, that's why it's taking a long time, but we can see that we've output some JSON files and we've got some changes here. We've got, well, the OWL file isn't going to show the diff. Yes, so let's go back to the beginning. The point, again, of SSSOM Curator and of doing all of this is that we want to capture mappings with high quality and thorough metadata. And so this is most importantly keeping track of what's the predicate that's being used to map two things together. Typically, this is something like from the SCOS vocabulary, like an exact match, a broad match, or a narrow match. When possible, sometimes you can be more powerful with your mappings and you can use axiomatic equivalences from the OWL vocabulary. And when you're not really sure, you have to default to using the database cross-reference relationship from the OBO and OWL vocabulary, which is how most ontologies in the OBO worlds and other worlds that use similar technology stacks will use this as the predicate for a mapping where the context isn't well known. So typically we don't want to use that. We go through and we do this curation so we can assert higher, more precise predicates. It's also really helpful, and because of this required in SSSOM, to include a mapping justification. And this means that you either did a manual curation, you produced it by lexical matching, or a small group of about 10 other possible ways of creating mappings. And keeping track of this is helpful for assessing the mappings. Now, we also have the benefit that because we're doing this workflow, I glossed over it, we get predictions that have confidences associated with them. So the confidence of those predictions are propagated through in the SSSOM files that are predicted. And once they're curated by a person, those confidences are not propagated anymore, because the human choice of saying this mapping is correct or not is more or less always correct. We do have the possibility for representing confidence in people's curations, and SSSOM also has built into its format sort of a two-layer system for the person who asserts that the mapping is correct. That's the author of the mapping. And then there's also the possibility to have a second curator check, and that's the reviewer. So there's different slots within the SSSOM specification for that. SSSOM Curator does not implement that at the moment because that's not something that we're typically doing, but it could be something that we work on later if that's something useful, especially for the NFDI. And so again, why are we doing all of this mapping stuff? The point is that we want to be able to sort of assess what are overlaps between different ontologies, controlled vocabularies, databases, resources that give semantic space, that create semantic spaces by giving identifiers or accession numbers to things. And more importantly, we want to use mappings to support the semi-automated assembly and integration of knowledge and the construction of knowledge graphs, because we have many different resources that use different vocabularies, and they are mappable to each other. However, those mappings are not existing most of the time. Okay, so that's it with respect to the curation. So SSSOM Curator really straddles the line between the format itself, SSSOM, and the workflows for actually creating content in SSSOM. The looking forward towards these bigger goals that I just mentioned of automatically constructing knowledge, I think the next steps towards that fit in other software that I've created. I think maybe it's worth mentioning the Semantic Mapping Reasoner and Assembler, SEMRA. This is another piece of software that sits on top of SSSOM and other related mapping formats that imports and consumes mappings at scale, and then does inference over them and does confidence assessment, and really uses a lot of information, previous domain knowledge about which mappings maybe can we automatically infer, or maybe if the mappings haven't been annotated super well, we might have some knowledge that even if a predicate is missing, for example, that we know what the kind of predicate is. So that's like the next step is assembling all of these mappings into sort of a coherent way. And then on top of that, once you have a very large and well-assembled set of semantic mappings, then you can apply that automatically to data that's in certain formats using certain identifier standards. And then you could automatically turn it into whatever your canonical preferences are for what's the most important vocabulary to use or ontology to use. Okay, so yeah, the last couple minutes of this weren't really about the software anymore, but they're really giving context for how all of this sits together. I hope this is useful. There's all sorts of places to look for more information about SSSOM Curator and about this. I think my blog is a good place because I typically end up writing down these things as blog posts. I think that the documentation is also a good place that gives a lot of background just to recap on the things that we just talked about in case you want to read this as text instead. Let's say the most important part would be like this creating projects part of the documentation. I basically went through all the stuff that's in here throughout this screencast. So not really sure where to end. This feels like a pretty complete video. Thanks for listening. Obviously, if you have questions about SSSOM Curator, a good way to ask those questions is to kind of go onto GitHub and to go into the SSSOM Curator repository. So that's inside my personal namespace now until we find a better place for it. There's like an issue tracker where you can ask questions about this, or if there's some problems, maybe like the one that happened earlier during the demo, like report a bug. There's also the Biomappings repository. So this is inside the Biopragmatics. So this is like my organization where I keep a lot of these other biomedical focused applications of these core semantic technologies. So if you have specific questions about that, you can ask there. I think one thing I did gloss over also is the fact that this very, very high level interface exists and it's set up in a nice way on my computer makes it easy to show this demo in a very small amount of time. But if you're thinking about extending it to new ontologies, new vocabularies that you're interested in, this is a time to get in touch with me and collaborate So I think that's a good place to leave it. So thanks for listening. I hope that you have some happy curating going forwards.